Hey guys, how are you doing? In today's video, we are gonna compute several derivatives. So grab your pen and paper, and I'm gonna see you in a minute. Let's start with a little warm-up. So we have f of x, which is equal to x to the power 5 plus e to the x plus 3 plus the log of x plus the sine of x. So we have no specific rule to apply, so we can just differentiate each terms one by one. Therefore, we get that f prime of x is equal to x to the power 5, its derivative is 5 times x to the power 4. Indeed, what do we have to do? We have to take the exponent, put it in front, and then we have to raise to the power of the exponent minus 1. Plus, the derivative of e to the x is just e to the x, so it stays there. The derivative of a constant, which is 3, is 0, so plus 0. Plus, the derivative of the log of x is 1 over x, so just 1 over x, and the derivative of the sine is the cosine, so plus the cosine of x. Perfect, we have computed our first derivative. Let's now come to a more complicated example. We want to use the product rule. So what does the product rule for derivative tell us? It tells that whenever I have a function with the product of two, f of x times g of x, then its derivative is just the derivative of the first function times the second one taken normally, plus the derivative of the second function times the first one taken normally. Let's try to apply this rule to the following function, h of x equal to x times ln of x. And I want to compute h prime of x. So we have a product of two different functions, and x is going to be my f, and ln of x is going to be my g of x. So we can just compute the derivative as, first we compute the derivative of the f term, which is for us is x, so the derivative of x is just 1, times the second function taken normally, which is just the log of x, plus the first function taken normally, x, times the derivative of the second one, which is 1 over x. Now, we can a little bit simplify this expression in this case. Indeed, 1 times the log of x is just the log of x, plus x times the 1 over x is just 1. Perfect. So we have computed our first derivative using the product rule. As a second example of application of the product rule, I want to compute the derivative of h of x equal to x to the power 5 times e to the x. So, to compute h prime, now what do we have to do? We have to take first the derivative of the first function, which is x to the power 5, and its derivative is 5x to the power 4, times the second function, which is e to the x, plus the first function, so x to the power 5, times the first derivative of the second function, which is just going to be e to the x in this case. In this situation, we can a little bit simplify the expression, and we get that we can factor e to the x between both terms, and we get e to the x times 5x to the power 4 plus x to the power 5. A second really important rule for differentiation is the so-called quotient rule. What does it tell us? It tells us that if we have a function that can be expressed as f of x over g of x, its derivative is going to be equal to f prime times g of x minus g prime f of x. And up until now, it looks like the derivative of the product, so we are just applying the product rule, but we have a minus sign instead of a plus. But then we have to divide everything by g squared of x. As an application of this rule, I want to compute the derivative of h of x equal to x squared plus 1 over x to the power 3 plus 1. In this case, h prime of x reads as, what I suggest you to do is to first square the denominator, in this case x to the power 3 plus 1 squared, and now we proceed computing the numerators, terms by terms. The first derivative of x squared plus 1 is just going to be 2x, since the derivative of 1 is just 0, times the second function taken normally, which is x to the power 3 plus 1 in this case, minus the derivative of the denominator, which is 3x squared, times the numerator taken normally, so x squared plus 1. Perfect. You can go on and simplify a little bit this expression, and you get that in the numerator you can rewrite everything as 2x to the power 4 plus 2x minus 3x to the power 4 minus 3x squared divided by x to the power 3 plus 1 squared, which again can be further simplified as minus x to the power 4 minus 3x squared plus 2x over x to the power 3 plus 1 squared. As a second example of application of the quotient rule, I want to show you how to compute the derivative of h of x equal to the tangent of x, which, I recall you, is just equal to the sine of x over the cosine of x. Well, let's try to apply the quotient rule to the sine of x over cosine of x. So first things first, we square the denominator, so cosine squared of x. And then we have to take the derivative of the numerator, and the derivative of the sine is just the cosine of x times the denominator taken normally, but in this case is again the cosine, so I would have cosine times cosine, so I just get a cosine squared, minus the derivative of the denominator, and the derivative of the denominator in this case is minus the sine of x, so this is plus sine of x, times the numerator, which is again the sine of x, so I will get sine of x squared. Oh, but here sine of x plus the cosine of x is equal to 1, so I can rewrite it as 1 over cosine squared of x, where I used that the numerator is just equal to 1. The third, and arguably the most important rule for differentiation, is the so-called chain rule. It tells us how to compute the derivative of the composition of two functions f and g. How you do it? Well, you have to first differentiate the outside function, in this case f of x, and evaluate it at g of x, and then multiplying this result by the derivative of g prime, which is the internal function. Great. As an example of application of this rule, I want to compute the derivative of h of x equal to e to the x to the power 3 plus 2x. The first step is always to identify who is f and who is g in my case. Specifically for us, f of x will be e to the x, and g of x will be x to the power 3 plus 2x. Let's check if we have done things correctly. So if we have done things correctly, we would like that h of x to be equal to f composed g, which in this case is equal e, but instead of x you have to put g of x, which is x to the power 3 plus 2x. So these two expressions now are the same, therefore we have guessed the right composition of this function. Perfect. Now, what does the rule tell us is that we are gonna need the first derivative of f and the first derivative of g. Let's try to compute them separately. F prime of x is equal to e to the x, and g prime of x instead is equal to 3x squared plus 2. And now we are in perfect shape to apply the chain rule. Indeed, what I have to do is just read out the formula. We have to pick up f prime, but we have to evaluate it at g of x. What does it mean? It means that now I have f prime who is e to the x, and instead of x I have to plug in g of x, sorry, is going to be e to the power x to the power 3 plus 2x times g prime, and I can read it from there. This is 3x squared plus 2. As a second application of the chain rule, I want to compute the derivative of h of x equal to the sine of e to the x. As before, let's try to identify f and g. In this case, f of x is going to be equal to the sine of x, and g of x is going to be equal to e to the x. Indeed, if we try to do the composition, f compose g of x, what do we get? Well, we have to evaluate f at g, which means that I have to write down f, and whenever I see x, I have to plug into actually e to the x. So what do I get? I get the sine of e to the x. And since this expression and the expression for h are the same, I have done the correct composition. And now let's compute the first derivative of f and g. F prime of x is equal to the cosine of x, and g prime of x is equal to e to the x. And now I'm in perfect shape to apply the chain rule. So when I want to compute h prime of x, what I need to do, I need to first consider f prime, which in this case is the cosine of x, and evaluate it at g of x, so at e to the x. And I get the cosine of e to the x times the first derivative of g, which is e to the x. As the last example of today's videos, I want to compute the derivative of h of x equal to e to the x squared times the sine of x. So you can immediately see that we are gonna have to use the product rule between these two functions. But you also remember that for the product rule, we have to take the derivative of each function separately. And here, e to the x squared is gonna be a composition of two functions, so we have to use the chain rule. So how to tackle a problem like that? What I suggest you to do is first call g of x to be equal to e to the x squared. In this way, you can rewrite h of x as g of x times the sine of x. So now you can compute easily the first derivative of h of x by using the product rule between these two functions. So h prime of x is going to be equal to g prime of x times the sine of x plus g of x times the cosine of x, where here I just apply the product rule between the functions. Now for this expression, I know what's the cosine of x, I know g of x is just going to be equal to e to the x squared. What I don't know is g prime. So now I have just to compute g prime of x, and this is going to be a chain rule between e to the x and x squared. Therefore, we are going to get e to the x squared times the derivative of the exponent, which is just 2x. And now I can substitute everything in h prime, getting that h prime of x is equal to 2x e to the x squared times the sine of x plus e to the x squared times the cosine of x. So this is how you combine two more complicated derivatives. That's all I have for you for today. See you in the next video.